Is that better? Oh, okay. It was the. All right. I'm Paul. I live in the city of Austin in the state of Texas in the United States. I work at Civitas Learning, a company that helps university students succeed. I will try and speak slowly. The AWS pricing is for US regions, and the pricing will be in USD. Let's begin the talk. So what is the goal? The goal is that I was given was, the goal that I was given was to reduce the costs by $500,000. So in October 2023, I got pulled into a meeting with the CEO of the company. And he said we had to reduce our infrastructure costs for the next year by $500,000. And this was one of the OKRs of the leadership team at my company. The OKRs is the objectives and key results. That's usually the goals that the leadership team at the company has. And we were seeing a gradual rise of the AWS bill over time, as you can see, and it wasn't a good situation for the company. So how do you begin a cost reduction project like this? First, I'm going to talk about the wrong ways to begin this project. One wrong way is to say that this is not my team's responsibility. We're going to focus on something else. Of course, if the CEO says that this is a goal of the company, it should be your goal as well to help the company succeed. Another wrong way is to engage with a vendor to reduce costs. Now, lots of vendors and consultancies will say, oh, we can help you achieve this goal, but there's a bit of a conflict of interest. You're going to try to reduce costs, but then you're also going to be paying the vendor money is one issue. Another issue is usually for some vendors, they will only provide recommendations. They won't actually take the action to reduce the cost. And the recommendations is the easiest part of the cost reduction. Sorry. Oh, it disconnected. The Zoom disconnected.
Disconnect? Okay.
Yeah.
Maybe you can use this.
Hello? Yes.
Oh,
no, it's not. It's still loading. It says your screen share is loading. It's not loading it. Let's try it like this. It's loading. I went to the this one because the other one wasn't working. Is this one bad maybe? Let me try that.
Okay, that's good.
No, shoot. Try the ship Wi-Fi maybe. What's the password again? Yeah, it's over there. I can't see it. The Zoom disconnected. What's the Wi-Fi password of the ship Wi-Fi? Yeah, I can't see it from there though. Okay, because it wasn't connecting before, so I switched to the other one, but then the screen share stopped working.
Right now, whole B is trying to resolve the network problem. Now trying to connect to another Wi-Fi. Please wait for a moment. Sorry.
Hello? Hello? All right. Sorry for the technical difficulties there. Okay, the wrong way to begin the cost reduction project is to say, this is not the responsibility of my team. We need to focus on another thing. Another wrong way, I think, is to engage with a vendor. And it can be a way to avoid accountability, to find a scapegoat if you fail to reduce the costs. Another wrong way is to immediately engage with Amazon and ask Amazon, how do I reduce our costs? You can do that later, but it's the wrong way to start. Another wrong way is to say we need to develop a whole new greenfield platform. Another wrong way is to say, oh, I'm 10% of the team, so I'm only going to be responsible for 10% of the cost reduction project. And then another way I don't think works is to say, we're going to move everything on premise, and that's how we're going to reduce our costs. So there's like you can, at the very start of the cost reduction project, already take a wrong approach. But there's a very common wrong approach that I see, and it's this. You have a core production system, let's say, and this core production system has a lot of customers, it's making you a lot of money. So you say, okay, our core production system is very messy and expensive, so we're going to build a whole new core production system with the modern technology that will be a lot more efficient and cheap. So we're going to have the entire team focus on this new core system project, and then we're going to migrate from the old costly system to the new efficient system. And once we finish the migration, we're going to shut down the old system. This is a very common approach people will take when trying to save money, but this is very dangerous to take this approach. It can actually result in spending a lot more money. So what's the mistake with that approach? So the intentions are very good. You want a more efficient system. You want to save money, but the approach isn't effective. So the first mistake that you're making is that you didn't understand the goals of the leadership team. So the leadership team, when they say we want to reduce the operational costs, they mean for that year. They don't mean for the next year, because every year they have a certain budget they need to work with. And if the cost reduction doesn't happen until next year, then it's very bad for the finance team. The second mistake is you're taking the waterfall approach. You're trying to put all your eggs in this, you're trying to put all your focus in this one project where you can't deliver incremental progress. So it's better to make small incremental progress that you can then share with, that you can then share the results more quickly. And the third mistake is that you have this idea that you're going to fully migrate and the old system will go away forever. And in my experience, that doesn't happen. The old system that you want to replace is still going to be there for some edge use case. This one customer, they need the old system for some reason, and they're going to complain if they have to go to the new system. So that means that for a time, you're paying the AWS cost of the old system and the new system combined, and it actually leads to an increase in your AWS bill. So the correct way to approach this cost reduction project is to understand your leadership team's goals. You want to track your costs on a last 12 months basis, LTM. This is how a lot of finance people understand it. And you want to look at the whole operational costs. You don't want to move something from AWS to a different vendor and say you reduce the AWS costs, because that doesn't actually count. You want to target a specific number, and you want to make sure that this is your highest priority. And you need to have the support of all the other teams at your company. And what you want to do is write down each different item you use to reduce costs on a spreadsheet so that you can sum up all your efforts and together. And you want to work with all the different teams across the company so that you can achieve this. So now that you've started writing down the different tasks for reducing costs, now you meet with the AWS team. You tell your AWS team, okay, this is how we plan to reduce our costs. Do you have any suggestions that we can add to the plan? And now their suggestions, you'll see them in the light of your other proposals. So for instance, the AWS team might say, oh, you can save costs if you put this microservice on reserved instances. But if you already planned on getting rid of the microservice, you know it's not needed. They might want a private pricing agreement, but that actually will stop you from lowering your costs because it locks in a minimum spend. So let's talk about the AWS account team. You have the executive account manager, and it's included in all your AWS accounts, but actually their goal internally at AWS is to make your costs go up, is to grow the account. You have a solutions architect, they have a similar goal. They want you to grow your account. They will tell you ways you can bring more things into Amazon. If you say, oh, we want to reduce our costs, suddenly they don't want to talk to you. The technical account manager will talk to you on reducing costs, and they can help you a lot. But in order to have that, you need to pay for enterprise support, which costs a lot of money. So you don't want to guess, you don't want to change something and say like, oh, I think it saved this amount of money. You can actually calculate it with Cost Explorer. So what I do is I track the cost reduction on a daily basis. I put in the spreadsheet, this is the day you made the change on, this is the change that was made, and this is a Cost Explorer link. And in the Cost Explorer link, you can put down the costs for 3 days before you did the change and 3 days after you did the change. You average each of those, and that will get you your daily run rate savings, the daily amount that you're saving on costs. So you need to keep working at this because you save one thing, but it's there's always going to be, you want to keep like adding to the spreadsheet even after you've hit the goal. And the reason for this is because in terms of run rate reduction items, we actually hit $800,000. But in terms of 2023 estimate, based on like when the item was implemented, it was more like $700,000. But the actual amount our bill was reduced by was $350,000. And that's because there was unexpected cost increase during the year. I call it like surprises. So some of them were, for instance, the price of spot instances in 2023 increased. And that was not something we had control over. Some of the stuff we maybe had control over, like we had to increase the size of some databases. And so you could say, oh, well, we failed to hit the $500,000. Executives have this silly thing where they set unrealistic goals, and then if you get partway, they still count it as green. So I'm not going to talk too much about the 2023 surprises, but let's talk about 2024 because there's some surprises that will increase your costs if you don't take any action. One of them is Amazon is now charging for every single IPv4 address, even if it's attached to a NAT gateway, even if it's attached to an instance. And this is a new change they're making, and it's not going to, they're not adding any new features. This is just a pure cost increase they're putting on their customers. And why are they doing it? Because it's going to make them an extra $1 billion per year. That's the only reason they're doing it. Another change they're making is legacy RDS databases will now have an extra cost once they hit their end of life period. So if you have MySQL 5.7 databases, Postgres 11 databases, or Postgres 12 databases, you're going to have an extra cost that you're going to have to pay starting very soon. Similarly, with Amazon EKS, if you have not kept up with your Kubernetes version updates, you're going to have to pay an extra cost. It's actually going to multiply the cost of your control plane by 5. It's going to be 5 times more expensive for the older versions than it is for the current versions. And this is all new price increases that Amazon is introducing this year. You can see this here. Amazon is starting soon. They're going to add new pricing, and for even future versions later, they're going to have some new pricing. So now we're going to deep dive into the specifics of reducing costs. So I'm going to, I can't cover every single Amazon service because there's a gazillion of them. There's a whole huge number of Amazon services. But I will try to cover the most common ones and how you can reduce costs with those. So I'm going to go over identifying cost-saving proposals in Cost Explorer, how to know what to do next to reduce costs. I'm going to go over deleting resources from Amazon and screen testing them. I'm going to go over EC2 spot instances and how they can save you money. I'm going to go over reserved instances and savings plans and how they can save you money. EBS cost optimization, RDS cost optimization, S3 cost optimization, and managed NAT gateway cost optimization. So first, let's talk about identifying cost savings proposals. The first thing you want to do is you want to unify all your AWS accounts as much as you can into a single organization. And the reason for that is that will give you a place to go to view your entire AWS bill all together. And if you log into the billing dashboard of the master account, then you can filter by your sub accounts and you can see, okay, which AWS accounts are costing more and which ones we don't need to be concerned with. The second step is you need to enable these Amazon managed billing tags in Cost Explorer. In Cost Explorer, you can sort by billing tag, but only if you enable it. So these Amazon ones, you should basically always enable. The auto scaling group, the batch compute environment, stuff like that will make it much easier to figure out what exactly you're spending money on. Thirdly, you want to enable cost anomaly detection. There's a fee for this, but it's very small, and the amount of money you'll save from detecting cost anomalies will be much greater. So when you're looking through Cost Explorer, you want to aggregate your costs by net amortized costs. And this will give, this will mean that when you're looking at the graph, it will actually accurately show your usage rather than having big spikes when you pay when there's a reserved instance. The other thing you want to do is go to charge type and exclude the credits, because otherwise the credits will be applied all over the place in a, I don't know what formula they use to apply the credits, but if you don't exclude the credits, you might be hiding some costs. So one of the issues with the cost anomaly detection is that it doesn't work properly under a savings plan for EC2 costs. You can see in this graph that our EC2 costs jumped up, but it didn't report an anomaly. And this is because the cost anomaly detection does not look at the net amortized costs. And that means that for some reason, it is not detecting this. This is a bug in the cost anomaly detection, basically. Hopefully Amazon will be able to improve this in the future. Next, if you're using infrastructure as code, one feature of Terraform is the AWS provider has a default tags option. So anything you put in that will be applied to everything in the Terraform repo. So I like to put Terraform equals true and repo equals what your repo is. And if you do that and you enable the tag in the billing dashboard, you should be able to see all the which repositories of Terraform cost more and which are cheaper. There's no easy solution, though. You need to regularly stare at your bill. You need to regularly have meetings and talk about, like, okay, the bill increased here, what's going on here, and coming up with techniques to reduce the bill, not always super clear, but I'm going to try to cover some common ones. So we were able to enact over 60 cost-saving measures, save a lot of money, and part of that was continuously meeting and reviewing the bill every month and trying to figure out how we could do better. So one approach to saving money, just delete stuff. One of the challenges with that is it's difficult from looking at a resource to know 100% if it's being used or not. It's like there's no way to prove something is not used. So rather than trying to figure out 100%, you want to think, okay, what are the risks and what is the payoff? Like, if we delete this resource, what is the risk to the reliability, and what is the payoff in terms of cost savings? And one approach here is scream testing. Just turn it off, see who complains. So to begin a scream test, you want to identify the cost savings, you want to identify the risks, and you want to have a rollback plan. And this is how you can this is a good way to do it, is to remove the security groups from the resource. The reason is all these different Amazon services all utilize security groups. So this works against across a bunch of different services. And this is also instantly reversible. If you back up and delete an RDS database, to restore it, it will take quite some time. But if you remove the security groups and there's an issue, you can instantly put the security groups back. When you remove the security groups, of course, it won't save money. So you need to follow up and actually delete the resource if no one screams and the resource is actually not being used. And this is how you do it. You can just go down, change security groups. And so, for instance, we deleted unused Amazon workspaces and we were able to reduce our costs quite a bit like that. Next, we're going to go over spot instances. Spot instances are amazing. And that's spot instances, the instance itself isn't reliable, but if you have a redundant architecture, then it should work with spot instances if you have a modern redundant architecture. And people think, oh, isn't there a trade-off between saving costs and reliability? Actually, no. If you use spot instances, you will have a more resilient system. And that's because you're engineering for instances failing. And even if you use on-demand instances, instances will still fail. So if you plan for that and use spot instances, you actually have a more reliable system and a cheaper system. One issue you can have is that sometimes you won't have spot availability. In order to not experience that, you want to use the most instance types possible. So if you're using EKS, you can use Carpenter. If you're using EC2, you can use attribute-based instance type selection. And for the others, you just need to use infrastructure as code to dynamically select the instance types. Next, we're going to go over reserved instances. So there's reserved instances for a number of different services, and the implementation is actually different for each different service. So for EC2 instances, reserved instances, I wouldn't recommend it. And the reason is because EC2 instances support savings plans instead. And savings plans are like reserved instances, except they work with any instance type. So it's much more flexible. It's much easier to view in Cost Explorer. And it's just overall a good idea. Redshift, you should use reserved instances if you have a static Redshift cluster that you never shut down or restore or start or stop. You can use reserved instances. If you have them going up and down all the time, I would say to not use reserved instances. OpenSearch, even if you have a static cluster, you still shouldn't use reserved instances. And that's because with OpenSearch, reserved instances are not convertible. That means if you have a smaller OpenSearch cluster and you increase the size, it will no longer be valid for the reservation, and you'll be paying for the reserved instance and for the instance price, and it will increase your costs quite a bit. But for RDS, it's the opposite. RDS reserved instances are convertible, so that will allow you to scale up your RDS database without it canceling your reserved instance. So RDS reserved instances, that's one of the easiest ways actually to get quite a lot of cost savings. But before you purchase your reserved instances, you want to make sure you're using the best instance type. So yeah, using more reserved instances, more spot instances, we were able to lower, and by shutting off resources, we were able to lower our EC2 costs quite a lot since starting the cost reduction project. Next, I'm going to go into Elastic Block Store. So Elastic Block Store, you want to use GP3 as much as possible because it's cheaper and faster than GP2 instances. So you want to search your Elastic Block Store for IO1. Never a good idea. It's very expensive and the performance isn't good. It used to be a good idea sometimes back in the day. Right now, you want to try to get rid of it. GP3 actually supports quite a decent amount of performance, up to 64,000 IO operations if you're using it with RDS. So if you have less than 64,000 IO operations, you want to use GP3. You don't want to use other types of instances. If you have more, maybe you can use IO2, but it's going to be very expensive. You can see $42,000 a year for an IO2 drive. So you really want to avoid it if at all possible. So a better way, if you have something that's very disk intensive, is to use an ephemeral disk that's part of a storage optimized instance. because for an IO2 disk, you're gonna, just for one IO2 disk, you're gonna be spending a ridiculous amount of money. So we got rid of all our IO1 and IO2 BS volumes, and we were able to save a good chunk of money doing that. So RDS, Relational Database Service. Amazon's been trying to push Aurora serverless. They say, oh, it's magical and it will scale with your workload and you'll save all this money. That's actually not true. If you look at the price for a 16 gigabyte database, you're paying $8,400 a year for Aurora serverless. However, for the same thing that's at a constant rate, you're paying only $2,000 a month. So you have a huge multiplication of price, and the auto scaling doesn't make up for the fact that the price is substantially higher. So your best value with RDS, don't use Aurora, don't use serverless, use vanilla RDS with Graviton instance types and reserved instances. And you want to have a GP3 drive with at least 400 gigabytes, because that way you get 12,000 baseline IOPS for free. So Aurora, as I mentioned before, don't use it. Back in the days, it was this hot new thing, and they said, oh, it performed much faster than regular RDS. That's no longer the case. Now it's basically the same thing, except that they put an extra fee on top of it. So they have this extra fee, Aurora Storage IO usage, and that's per IO request you're paying for. And it sounds like, oh, 20 cents for 1 million. That's very cheap. But we're talking about IO requests, and no one knows how many IO requests they are sending. Usually you measure IO requests as a per second cost, not as a per unit cost. So actually it's quite expensive. And you can see we used to be paying for this IO request $3,000 a month. And when we migrated from Aurora to non-Aurora, we were able to substantially reduce our costs. Unfortunately, there is no easy way to migrate from Aurora to non-Aurora. They make it very easy to go to Aurora, but if you want to go back, you need to dump and restore the database yourself. And yeah, that's just how Amazon works, unfortunately. Next, I'm going to go into S3, Simple Storage Service. You want to verify all your compliance assumptions. So with compliance, people think like, oh, we need to store all this data. You want to make sure that it's actually true. So we thought, okay, we need to keep all our logs for at least a year due to compliance. It turned out that this did not include the VPC networking logs. It was only for the application logs. So in fact, the flow logs, we never actually used them to diagnose any issues. We were able to just stop storing them entirely. So you want to actually meet with your compliance team and go over the cost of each compliance requirement. And it's kind of funny. If you meet with your compliance team and say, okay, to comply with this, it will cost some huge amount of money, suddenly these hard requirements are no longer set so strict once people learn how much they cost. So definitely worth to not just assume something's required, but to actually verify it. And there is no compliance anywhere in the world that says you need to store data for an unlimited period of time. It's the default in S3 that it stores something for an unlimited period of time. There's no compliance that requires that. Every compliance record keeping requirement has an end date. So you want to make sure that so you know those end dates, and that you put lifecycle rules for those end dates to just delete the data. because there's no point in keeping it for longer than is required for compliance. There's different tiers for AWS S3. Most of the time, you want the standard infrequent access tier. Anything that's being downloaded frequently is probably being downloaded through a CDN. So almost always you want this tier. But you can only have this tier for things that are over 30 days old. So you want to create a lifecycle rule where whenever something's more than 30 days old, it goes to standard infrequent access tier. And there's intelligent tiering, and what that will do is it will do that for you, but it will also charge you an extra fee. You don't need to use intelligent tiering. You can just create the lifecycle rules yourself. If you have a huge amount of data and it's less than 30 days, or for some reason that's not working for you, you can also look into alternatives to S3, such as Cloudflare's R2. What I wouldn't recommend is Glacier usually, because when you transition the data, there's a fee, but it can be useful for certain long-term record-keeping requirements, but you need to keep into account the Glacier transition fee if you're going to use Glacier. So this is a script to get the size of all standard storage buckets. You can copy paste this from the slides. This is a bit unintuitive because you actually need to call CloudWatch, not the S3 API, to get this. But I thought this might be useful to people trying to figure out where their S3 bill was coming from. And so once we implemented lifecycle rules to delete stuff after the record keeping requirements, you can see our costs went down quite a bit. Now we're going to get into NAT gateways. This is something people know is like a ripoff. And that's because the network functionality required to run a NAT gateway in a redundant way, Amazon doesn't provide it as part of Amazon Cloud. You need Anycast or multicast, and you can't do that in AWS. So if you have a huge NAT gateway cost, one way to reduce it is to route the traffic through private link. If you're pulling a lot of data from S3 or images or container images from ECR, but you need to keep in mind that to run the private link, there's an hourly fee. So you need to download a gigabyte per hour over the entire year for private link to be cheaper than using the NAT gateway. And if you really want to, if you have really high NAT gateway costs, you can create your own NAT gateways. However, this will decrease your reliability, as there's no way to have a redundant NAT gateway in AWS by building it yourself. So you need to have scheduled downtimes, and you need to sort of run the risk of it being overloaded. So you need to monitor that and have alerting for that. And the break-even point for that to even be cheaper is 3,000 gigabytes downloaded per year through the NAT gateway. So it's one thing you can consider if that's a significant amount of your costs. And finally, Kubernetes cost optimization. This is a good Prometheus query to run to see what is. So if you're using Kubernetes, this is a query you can run to see what is requesting a lot of CPU cores. Now, generally, something doesn't need a CPU core because that would be maxing it out. So you want to request like a small amount of CPU, like what the average of the usage is, rather than what the max usage is. Thank you very much. Every organization is different. There's a lot of experience I'm lacking. I'm happy to answer questions about your specific use case of you want to optimize your costs in the hallway. But if you have questions about the presentation, be happy to answer them now. Thank you. Yes. Oh,
Okay,
Uh,
thank you. Go ahead.
Just wondering that during this exercise, did you ever also consider like a different cloud, just comparing the cost of like during this project?
no, because it wouldn't be very agile. A lot of people view cloud migrations in a very waterfall way, where we're going to migrate everything, and it's going to reduce our costs once we finish migrating everything. But that's not how cloud migrations actually work. How cloud migrations actually work, you migrate one part, then you migrate another part, then you migrate another part. And if you look at the pricing, there's the pricing between the major clouds is similar enough that if you migrate just one part, you're not going to save enough money to make up for the extra engineering complexity and burden for the fact that you're now multi-cloud. There's no way to do a cloud migration from one cloud to another cloud without going multi-cloud, because you're always going to have an in-between part where you're multi-cloud. And when you go multi-cloud, complicates things a lot. So you need to, Microsoft will try to sell you on it. They'll say like, oh, we'll give you like so many different credits and discounts. All that's sales and marketing. I wouldn't put too much stock in it. If you want to do multi-cloud, you need to actually do the math in terms of like, oh, how much will leveraging other clouds save you? I gave an example for R2 that if you have a huge S3 bill, that's one way you can start doing multi-cloud by going to R2. But you need to do the math and make sure it's worth it. Like you need to say like, oh, we're going to save exactly this amount. What you don't want to do is say, this is how much we'll save if we completely migrate, because that gets back to the core slide of my talk, which is the this. Basically, trying to move clouds completely is this. It's saying like, oh, we're going to move the whole thing, we're going to revamp the whole thing, and once it's done, that will be our cost savings. And that's the waterfall approach that will lead to a difficult situation, because once you actually start doing it, you're multi-cloud, you're moving things a bit at a time, and the costs actually are not decreased.
Thank you. Oh,
Thank you for the presentation. Actually, kind of similar question, but a slightly different approach. As a person who has also undergone kind of similar kind of cost reduction problems, have you considered data reduction jobs, for example? That, you know, we tend to put a lot of things in S3, but we never prune them, or we never use cold storage, or for example, for the database, you know, all those IOPS operations increase because we have a lot of unnecessary data. So maybe we can have like passive databases for data that is not very active. Were that part of your consideration in the cost reduction?
We've definitely done stuff like that, where we look into so here, one of the reasons, so with S3, I gave this script. This will show you, okay, this is where we're hoarding all this data. And once you see like, wow, this bucket is costing this so much money, then you start to think, wait a second, why do we have all this data? Is it really needed? Do we really need to go through all this data processing all the time? Like, what's the business value of it? But those are very kind of use case specific things, but they're definitely core parts of trying to reduce costs. Does that answer your question? Yeah. Thank you. Yes.
sorry, it's the time. Okay. Please contact him after this. Okay. Sorry, it's time. So now, after this session, we will have another talk at 4 p.m. Until 4. This is a break time. Again, thank you.